All right. So we have this signal which is a half cosine shaped spectrum. All right. Express it as a function of frequency. That means you have to see what is XF. Okay. So this is half a cycle, right? Half a cycle. So the full cycle will be 4, right? Because half a cycle is 2. From minus 1 to plus 1 is 2. Full cycle will be 4, right? Okay. Now again, many of you may have difficulty thinking in terms of frequency here. So I would recommend is think in terms of time first and convert that to frequency. Imagine this is T, and not F. If this was T, alright, so I change this to T. Easier to see, right? Then I have a period of 4, right? And an F naught of 1/4, right? That means I will have a cosine of 2 pi F naught T, right? This is what it will look like. Now I change back the frequency. So this will be the same as cos 2 pi 1/4 F. So that is what that is, times a rect of 2. You see? Because it has cut off everything from here. So that rect is from minus 1 to plus 1, so it's a width of 2. Do you see it? Still don't see it. This cosine wave will continue on like that. Yeah. But now I'm only taking up this part. Yeah. So that's why I can multiply by a rect. Can you see it now? Still cannot see it. Okay, good. Because you did not reply, so I think you don't know. Okay, you have to tell me, okay? Huh? So in fact, this is what is your XF. Huh? Because we always say cos 2 pi ft, what? That's the cosine wave. Right? If I have a cosine wave and the wave has a frequency of 5 Hz, it will be 2 pi times 5t. If I have a cosine wave and it has a frequency of 10 Hz, it will be 2 pi 10t. That's what the F is, isn't it? Yep. Right? Okay? So we found that our F here is 1/4, and that's why I put 1/4 here. Alright? And then I did a change of variable to move it back into the frequency domain. So that's my recommendation. And you don't have to do it that way, but because we can see things better in time domain. Alright? I need to change the battery. So what's the maximum frequency here? 1. So what's the Nyquist? 2. Right? So FM is 1, therefore Nyquist is 2, FM will be 2. Okay? Okay? Next. Instead of sampling at the Nyquist, the signal is sampled at 4 Hz to obtain XS. Derive an expression for XS in terms of X. So now we have XS is XT sampled at 4 Hz, 4 Hz, right? So that means our Fs is 4, our Ts is 1/4, right? Okay. So So it's going to be sampled. So this is my sampling waveform. Okay, KTS. So that's the formula there. Okay? So that's B1. Then let capital XS denote the spectrum of little xs and derive an expression for capital XS and sketch it. So I find the Fourier transform. XSF is XF. Multiplication becomes convolution. This guy becomes 4. Right? So I'm going to take XF and repeat this because of the convolution at multiples of 4 Hertz. So XF, which is this guy here, will be at 0, 4 Hertz, 8 Hertz, 12 Hertz, etc.
Okay.
Correct? Alright, so this guy, I can put it this way. Alright, of course I can substitute this one inside. Substitute this inside. But that's straightforward. You can do that. So if I do that, it will look like this. Okay? Okay? And that's question 2. Can you or not? Okay, everyone?
How about question 1? What's the question 1 for?
Question 1
For this year?
is our this year. That one you got to read in 2 weeks' time.
This question 1, question 1, the question 1.
Okay. I'm just kidding you guys.
Oh, okay.
Oh, this one, right.
Oh,
That's familiar.
This is when you use the properties, when you use your replication. But of course, we don't have the Fourier transform here of this guy. You have used integration for this.
Integration.
Yeah. Because the Fourier transform table doesn't have the decaying exponential. The decaying exponential we've done before inside the lecture.
You replicate the template.
Then you replicate this. Once you find XF for this, right, then you're replicating.
Yep.
Same problem. Same problem. Only different is the waveform, that's all. Alright? So this one you got to integrate. Yeah.
How do you know that FM is 1?
If FM is 1,
How do you know it's 1?
how do we know? What is FM? FM is the maximum frequency, right? What's the maximum frequency here?
This is around 1.4.
What do you think it was? What's the maximum frequency in this signal? This is frequency. Got it? Alright?
Question 3.
Question 3. Is it okay? Question 3? We go to question 3?
Still for us here.
Alright. Figure Q3 shows the discrete frequency, magnitude and phase spectra of a periodic signal. So there's magnitude and there's a phase. When the Fourier series coefficients is given by this, find Fp and Ck. Fp is the fundamental frequency, as you can see. Fundamental frequency. And Ck are all the Fourier series coefficients. Alright, so what's the fundamental frequency? What are frequencies here? 3, 4.5 and 6, right? Those are the 3 frequencies. So the fundamental frequency will be the HCF, isn't it?
Yes.
Okay, so we want to find the HCF of 3, 4.5, and 6. Can you figure out what it is? 1.5 lah. Correct? That would be the HCF, right? Everyone can find that, huh?
Yeah.
I don't have to go through that, huh?
Okay.
So that means this guy, K equals to 2, right?
Yes.
This guy, K equals to 3, right? And this guy, K equals to 4, right?
Yes.
Second, third, and fourth harmonic. Because 2 times 1.5 gives you 3, 3 times 1.5 gives you 4.5, and 4 times 1.5 gives you 6. Do you agree? Alright, then this FP will be 1.5.
Okay.
Right, the fundamental frequency. And then he asks you for the C case. So 2, 3, and 4. Right? So that means XT, let's take the 2 first. Where's 2? 2 is these two guys, right?
Yes.
Agree?
Yes.
So this one has a magnitude of 5 and a phase of plus and minus pi over 6. Alright? So 5 e to the j, let's take the negative first. Pi over 6 times e to the j 2 pi 3. So this is for this guy. 5 times magnitude phase at a frequency of 3.
Why is not minus 2?
Huh? Sorry?
Minus 3.
Sorry, thank you. Minus 3. Alright, and then you have the positive one. 5 e to the minus j pi over 6 at a frequency of j 2 pi 3 t. Correct? So 5 based on minus pi over 6 at a frequency of 3. Alright, you need to know how to write all these expressions. Huh? Alright, then let's take the next one. Minus 4.5. 4 at the face of pi over 4.
The same thing.
Same thing, I got to write it down first. Because it's what it's asking you. Alright? So the second one is 4 e to the pi over 4, right?
Over 4 times
E to the
G
j 2 pi minus 4.5 plus 4 e to the minus j pi over 4 e to the j 2 pi 4.5 t. And finally, for the plus and minus, 6 is 2 and pi over 3. Okay?
Yeah.
2 and pi over 3. 2 pi over 3 e to the j 2 pi minus 6t plus 2 e to the minus j pi over 3 right? So those are all the guys. And don't forget there's a DC as well of 3.
Okay.
Right?
Yeah.
DC of 3 plus 3. Okay, so now I can label this. So this guy is for K2, right?
Yes.
So this is C minus 2. This is C2. This is C minus 3. This is C3. This is C minus 4. And this is C4. And this is C0. You see all the coefficients now?
But 5 marks need to write quite a lot.
No, I'm doing it slowly so that all of you can follow.
Okay.
Huh? Of course, you can do it faster, lah. But I want to make sure everyone is able to understand it. Huh?
Okay.
So you just
Is that okay? Huh?
So you just leave our answer like that.
Yeah, I can leave it like that. As long as it's clear. This is very clear, right?
Yeah.
Clarity is important. Okay, of course now I've got a long board, I can write this, you can write in multiple lines. Okay? So if you are very good, you don't have to write this because you can immediately see from here. But up to you lah. Up to you. Okay, so I'll answer question 1A, 3A. Label and sketch the power spectral density. Power spectral density is what?
H square.
Px is summation
Exactly.
of ck squared, right? So basically, I take this, I square this, square this, square this, square this, square this, square this. Okay, now? So this will be 9, 25, 16, 4. 9, 25, 16, 4. That will be your power spectral density.
Okay.
Right? So you get that. This is 3, 4.5, 6, minus 3, minus 4.5, 6. So, up to 25, 10, 20, 30. This is 30. This will be PXF. So the first one is 9. So it's here. Then 25. 25 is this guy. Then it's 16. Here. And the last one is 4. Here. Right? Okay. So this is, I label it now. So this is 9. This is 25, 16, 4. Okay? So that's part B. Huh? Because PSS squared is CK squared.
But this one is average power. This is density.
Yeah. Power spectral density. That's the definition, right?
This definition is regarding the average power, right? So,
Power spectral density.
okay.
Mod CK squared. Okay?
Oh,
So I'm just squaring it. Alright? Okay? And finally, what is the DC value and average power? So DC value is 3.
average power plus.
Huh? DC value is 3. And what is the average power?
Summation.
Average power with this guy, right?
Yes.
Which will be
Summation.
4 plus 16 plus 25 plus 9 plus 25 plus 16 plus 4 lah. Okay, you can work out the details, huh? Okay? So that's question 3. Oh, by the way, this is the paper for the BH group.
Oh.
Oh, our paper is different?
Your paper is usually a little bit easier.
Oh, that's good. That's good news.
Oh, they all need to
So this is not difficult, ah.
This one is difficult.
Okay, you didn't hear me say that, huh?
Probably you divide by 7.
Oops, I must delete.
What's the average? This is the total
You
power.
divide by 7, right?
There's no total power, it's always average power. You have total energy.
Oh.
So average power is just sum up.
The summation of CK, mod CK squared. Okay? Any questions?
Question 4.
You see, I can do all these questions now, but when you are looking at it yourself, the question is whether you can do it.
Mm.
Yes, That's why you have to try it yourself.
Question 4 is about sampling, right? Last year's
Well,
sampling
you'll see,
question.
you'll see. Energy.
Oh.
Bandwidth. Okay? Everyone good with this? Good. Okay. Okay. Consider the signal xt as shown. Let capital XF denote the Fourier transform. Applying appropriate formulas given in the table, find capital XF and a label sketch. Now, label sketch means that you got to see where all the numbers for the sketch marks are, for the grid marks are. Okay? That's what we mean by label sketch. If you just say sketch, then you don't have to put numbers. But label sketch, then you have to put the numbers. Okay? So we're given xt, 4 sin squared, 2t minus sin squared t. Okay, I hope you know how to use your Fourier transform thing, huh?
Right.
Okay? Correct. Right, this sin squared. Try.
Oh, right.
Okay, so xf is 4 over 2 try f over 2 minus try f.
Okay.
Can I? Use your formula sheet now.
Now a label sketch.
Okay? Can sketch or not?
Yeah.
Can or not? Got 2 try. Okay? Let's draw the first try. The first try is up to plus or minus 2. So this is the first try. Correct? What's the second try?
Sorry,
The
the
second
period,
try is minus, right?
the period is 2.
Huh?
It's so.
There's no period here. The duration is 2. I'm very precise about my language. Period means it's a repeating periodic signal.
Minus 1 to 1, right?
Huh? No. The duration. There's no period here.
No, the try is different.
Yeah, the duration is 2.
Other-
Because this is not a periodic signal. There's no period here. See, I'm very precise with my language.
Okay.
Otherwise, it confuses everybody, right? Yeah? There's no period, duration. Okay? Yeah. So this was described in chapter 1 when we said these are all the basic signals. And I told you that the way the definition of try is different from rect. Remember that? I said that, right? So this is this guy. The next guy is a minus try.
Okay.
So got a minus try here. It goes down like that. So you add the green and the red, what will you get? I will get this, right?
Oh.
Correct?
Oh,
When I add the red and the green, I will get the blue. So that's what you're supposed to sketch out.
Okay.
Any questions? So that's part A. Okay? Part B. Find the 3 dB bandwidth. So this is a spectrum of XF. Okay, so I clean it up now. So it's easier to see. if I find the magnitude of this guy, it looks the same, right? Magnitude, because all positive here. So I can also label this as okay? So 3 dB lambda is when I have the square of this and it goes halfway down. Right? In other words, mod xf 3 dB squared over mod x 0 squared equals to half. That's a 3 dB value. So instead of speaking of squared, since I have no square there, this is the same as saying mod xf 3 dB over mod x 0 1 over root 2. Same thing, right? So it's easier to see here. That means I have to go down by 1 over root 2. 1 over root 2 is about 0.7. Correct? Root 2 is 1.4. Right? 1 over 1.4 is about 0.7. Do you agree? Use calculator. Huh? So in other words, I have to come down to here to see what S. Okay? Got it? Do you understand what I'm trying to do? Huh? So, this is a straight line, right? Of slope 1, isn't it? Minus 1 and slope of minus 1. Over a range of 1, it goes up by 1. So, slope of 1. Over a time, over a distance, this is f. Over a distance of 1, the change is 1. 1 over 1 slope 1.
Okay.
Okay? So let me redraw this, because I want to find where this point is. So if I redraw it this way, it's easier to see. I'm going to draw it this way. One. Okay? And I want to come down to 0.7. I want to find where is this. Because if I can find where it is, I know this distance. And then it will be 2 minus this distance. Because that's what I want to find. Because this point here is my f 3 dB. Do you understand?
Yeah.
Okay, so it's easier to do it this way, right? If I go down from 0.7, isn't this also 0.7?
Yes.
That means this distance here, from here to here, is
1.3.
0.7, isn't it? Because that distance is 0.7, that 0.7. Therefore, f 3 dB will be 2 minus 0.7, which is 1.3. Approximately, I'm just giving you that.
Yeah.
You got it? You understand? You know why I did this way, so that you can see where this point is. So that I can figure out what this is. Okay? Okay, it goes back to this concept here.
And what is the right definition of?
That's the definition of 3 dB. And I do it in mod x rather than mod x squared, because it's easier to use this diagram.
So what is mod x squared?
What is mod x? Mod x is this guy.
Sub-zero.
Yeah. But I'm not using maths to solve this problem. I'm using the figure to solve this problem. I can use maths also lah. But I want to get you to understand the concept. Not so easy to try to figure this out here, you know. Theoretically, yes. But you'll be stuck with the two try there. You don't know what's the value.
Easier to analyze by.
Easier to analyze like this. Okay? Okay? So really, the correct answer, 2 minus 1 over root 2. That's the correct answer. Because this is 0.7. Right? I was using an approximation just now. Yeah? The 0.7 is 1 over root 2. So that's the correct answer. So that's the 3 dB battery. Okay? Okay, and the last part is determine this guy. So we are asked to find integral from minus infinity to of xt dt. What is this integral doing? Tell me. You've seen this before. What is this integral doing?
Energy.
No, but energy got not more. There isn't a mod xt squared there.
The error.
It's the average value of x, isn't it? Isn't that the average value of x? Isn't it?
Forgot already.
Yeah. How do you calculate average? Integral of the whole thing over time, isn't it?
But there is no overtime.
This time what? xt. Isn't it?